Hi everybody, welcome back to another exercise 3 video for ERM 4354. I wanted to help you guys with this assignment, and basically it's you might be clicking this. It's Let me look at the instructions real quick. You might be looking at this and be like, what the heck, there's so much on my screen, I don't know what to do. And actually, it's quite simple. All you gotta do is, you see there's auto liability, general liability, and workers' comp. And at the bottom here, you can see workers' comp, auto liability, general liability. We're gonna be taking a look at the worst case scenario for all three. And the point of this assignment, the purpose, is we are going to buy a risk transfer for each of the three hazards. The risk transfer should target the left tail of each distribution, and cost should stay within our budget constraint. Now, what does that mean? That means we're looking at siloed. We are making the expected cost of insurance risk transfer equal 40,000 for each individual risk. So in in reality, what we're really gonna do is basically exercise 2, but on a bigger scale. So now you might be looking, what is this number, 47 million? 47 million comes from adding 27 plus 7 plus 12. These three numbers for your worst case. That's what 47 million comes from. Now, what about this 29 million? Well, 29 million, or more like 30 million, it means that out of all these years, 10,000 simulated years, one of these years, let's see, my finger shows up, one of these years will have a worst case of 30 million dollars worth of losses across general liability, auto liability, and workers' comp. So what is the difference between the 47 million and the 29 million? These numbers together add up to 47 million. It kind of doesn't really mean anything other than, like, if these three numbers were to happen in the same year, if they were to somehow magically happen in the same year, that would be really bad. But this number would be here. What this 29-30 million dollar figure means is that in one year, the worst that can happen is that number. In reality, for actual firms, there's no way they can tell, um, is it going to be auto liability? Is it going to be general liability? How is this 30 million split among the three? There's no way they're going to be able to tell in the future, the amount of losses they're going to have like that. So, this risk financing tool is extremely limited, but it's meant to open up to the next assignment where we're going to figure out uh, kind of how to efficiently uh, value these retentions, and how much of a budget do we want to use. They're not going to, in this one, we're all going to have a $40,000 budget. But in the next few assignments, I don't know when, but in the next assignment, things are going to change. So for this assignment, we're looking at three individual risks, but all in a portfolio. We're going to be treating it as a mono line. So why don't we get started with that? We don't need to calculate for loading percentage because it's already been calculated for us. But we do need to find a $40,000 budget. So we're going to treat it just like we've always been treating it, and look at the mean and add two standard deviations to it. So the mean is, what is that? 2 million, and the two standard deviations is 2.4. So we're gonna do 4 million. Don't forget, that is not how you type that. Don't forget to put the negative sign. Oopsie, I put that in the wrong spot. And there's gonna be 1. Let me go back real quick. I don't think I should have done that. There we go. Negative. Let me just change that real quick. All right, I fixed it. So we're gonna put 4.4 million in there, and then we need to find the insurance limit of coverage. 4.4 million is what we're retaining, but 12.3 or 12.5 is the worst case. So why don't we put in a 8 million 8 million limit of coverage. Now, you might be looking at that and be like, dude, that's way too high. And you're right. So we're going to use goal seek, and we're going to change this value to 40,000 because that's the new budget constraint. And we're going to change this number because we're also looking only at the left tail because we know the left tail has the highest severity, lowest, um, lowest probability. So boom, as you can see, we got our first number. And if you look, there is a difference in the standard deviation. So why don't we start off now with this one, the general liability. Two standard deviations is about 2.5 million. So why don't we type that in? 2.5 million. And the difference between 27.5 million and that would be 20 million. What am I talking about? 25 million. 25 million. You can see that's way too high. So we're gonna what if analysis this number to 40,000, and we're gonna change this cell. See, we got a number there. This is a bit too high, so why don't we change this to 22 million? It doesn't really matter because we've gone in the correct goal seek, but if we do it too low, if we remove the 0, you could see that we haven't used enough coverage. But if we put just the right amount of limit of coverage, you can see that we have it properly done. So why don't we check this one? And you can see that that is the exact same. And if we look at workers' comp, just this row, just like we were just looking at this row, we're kind of siloing the risks, kind of doing it single but together. Same but different. So look at that. The mean is 3.6 million and the standard deviation is 1.8. So 1.8 plus 3.6 is 5.4 million. I can't do math, man. 5.4 million. And let's look at the difference between 5.4 million and 7.7 million. That's about 2.3 million, but let's round up. Let's round up to 2.5 million. You can see here that we haven't used enough budget. We're going to goal seek to get 40,000. Once you get in the groove of it, get into the groove of it, it's going to be very simple to type this stuff up. And I believe we got a different number. Let's check that out. Oh, I see why. I see why we got a different number. It's because this plus this does not equal 7.7 million. You can check that by doing equals sum of these two and close it. Oops. Why don't we? How do I? Actually, let's do this. Sum of that, but oops. Negative plus that. Boom. That should work. You can see how this number is actually still lower than this number, and we need to increase our retention. So why don't we make this 3 million? I typed a 2 in there, 3 million. You can see that we're over now, but if we use goal seek, change this to 40,000, once you get in the groove of it, it'll come fast to you, and the quizzes should be very easy. And you can see now that this number exceeds this one. And you've solved now for the worst case. Now, what Dr. Miller was talking about in class was that the numbers, you can see that they don't align altogether. They don't align. And that's okay, because that shows that this form of monoline is not efficient. And that's what we're here to learn about in this for this exercise, that we are currently siloing the risk and finding the worst case for each individual one. And you might be asking, honey, how do you know that? If you look right here in the instructions, it says in this exercise, we'll buy a risk transfer for each of the three hazard risks. The risk transfer should target the left tail of each distribution, and cost should stay within our budget restraint. What that means is you're doing 40,000 for each, and oops, that's exercise 2. You're going to do 40,000 for each and every single one, but you're doing them individually. You're not, when you're looking for the budget for workers' comp, you're not thinking about general liability. You're not thinking about auto liability. So you're kind of siloing it. And what we're supposed to learn from this exercise is that this is not the most effective measure, because looking at the worst case here, because we have 10,000 years of data, we're able to scroll down and look, but let's scroll down and look 2014, I believe. You could see that there's a gap in workers' comp. I think workers' comp was over here, and auto liability was over here. It's not efficient. You should be saving more money. But that's not the purpose of this assignment. The purpose of this assignment is just to learn that it's not an efficient process, and that in a future assignment we will be learning a much better way. But let's go ahead and look at the assignment that we have to do. And let's look at 3.1. If you look at the reduction in standard deviation, all you got to do for standard deviation reduction is you could see that there's auto liability, general liability, and workers' comp. Since we're looking for workers' comp, we turn off these two, and you can see that there is a difference between these two, and that'll be for workers' comp. To find it for general liability, you turn this one on, and you see that there's a difference for general liability. Then you turn it off, and you want it for auto liability, and you turn this one on, you can see there's a difference between these two. So that's how you answer reduction in standard deviation. To find the RF efficiency, remember, when you write down the reduction in standard deviation, make sure to divide that number. So for this example, let's say we were looking at auto liability. So the reduction in standard deviation is 76,682. 76,682. Excuse me. That's the reduction in standard deviation. To find RF efficiency, you divide by 40,000 divided by 1,000, or just divide by 40. And you'll do that for each and every one, and that's your RF efficiency. To find the combined ones, you just add up, just add up the RF efficiency for all three, and that's how you get the combined HPR or HRP. And then for reduction in standard deviation, you do the same. And when you look at those numbers, you're going to see that one is higher than the other, and you're going to see one is lower than all the rest of them. And that's how you answered 3.2 and 3.3. So these are very quick videos, but replay them as many times as you need to, and ask me any questions if you have them. But this was pretty much it. Thank you.